Good morning to everyone present here. I am MAHESWARI, working as a professor in the Department of CSE. So today we can see about the basic concepts of the Cypher techniques in the subject cryptography and network security. So before going into that, initially we can see what is meant by the plain text and what is meant by the cipher text. So while we are doing communication in the transmission in between the sender and the receiver, normally the sender will be sending the message to the receiver. So any third party, there is a possibility to attack the message and he may send any fault message to the receiver. So in order to avoid that, we are going for the cipher text, where at the sender side he may do some encryption technique such that the original message can be converted into some cipher text, which is considered to be a modified text, and then this can be sent to the receiver, and the receiver can change the plain text into cipher text into plain text by means of a key, and then he may access the original plain text. So today we can go into the various corresponding techniques in this cipher. So in the cryptography, these are considered to be the various terms to be considered. The first one is considered to be the plain text, which is the original message what the sender is going to send to the receiver. And the next one is considered to be the encryption. Encryption is a process where we are going to convert the original plain text into cipher text by means of a key value. And then the next term is considered to be the decryption. The decryption is done at the receiver side, where they are going to convert the cipher text into the plain text by means of the same key value. Then the next one is considered to be the cipher text. Cipher text is considered to be the modified text. So how the process is done means it is done by means of a symmetric methodology. Symmetric means here both the sender and the receiver will be sharing the same key. So see, the plain text is input is given at the sender side and he is going to send this message to the receiver. So while they are going to send the message at the sender side, first he will be doing some encryption algorithm. That is, the encryption is done by means of a key, which is considered to be the key which is shared by both the sender and the receiver, and it is considered to be the secret key. So here under encryption algorithm, there are various types of algorithms present. Initially we will be using the data encryption standard, the simplified data encryption standard, etc. So here by means of a secret key, they will be converting the plain text into some modified text, which is considered to be the cipher, and then they are transmitting this cipher text to the receiver. So at the receiver side, they will be using the same secret key which is shared by the sender, and he will be converting in turn the cipher text into the original plain text. So this process is considered to be the decryption algorithm, which is a reverse of this encryption, and in turn the original plain text will be received at the receiver side. So under the cipher techniques, there are various types of cipher techniques present. So initially today first we will be seeing about the classical substitution ciphers. So under this, what is meant by the substitution means we will be substituting for original plain text some cipher text in the form of either letters or numbers or some symbols. Then the next one is they are replaced by the cipher text bit patterns. So under this classical substitution ciphers, these are considered to be the various cipher substitution process. The first one is considered to be the Caesar cipher. Then the next one is considered to be the monoalphabetic cipher, Playfair cipher, polyalphabetic cipher, Wigner cipher, and transposition ciphers. So the first technique is considered to be the Caesar cipher, where under the Caesar cipher they will be replacing each letter in the plain text by means of the third position of the alphabet. That is, here they are considering the key value to be 3. For example, see here. Here under this, the cipher text is considered to be the encryption of plain text, which is given by P plus K mod 26, where this P indicates the position of the plain letter and this K indicates the value 3, and then we are going to do the addition of this with the mod 26. For example, initially we will be assigning the positions for the alphabet starting from A. So here it starts from 0, 1, 2, 3, this gives the positions. And then for the cipher text, for example, you consider now we are going to send the character A, then this will be encrypted by means of this formula, that is, encryption of A will be equal to the A position value plus the K position value. That means here the A position, the value of A is considered to be 0, therefore 0 plus the K value is considered to be 3, therefore 0 plus 3 mod 26, which will be equivalent to 3 mod 26, that is equal to 3. So the third position, 3 position letter is considered to be the character D. Therefore, for the original plain text A, after doing encryption with the K value as 3, it will be encrypted as D. So this is considered to be the cipher text for the value original text A. Similarly for the B, here the B value is B position is considered to be 1 and the K position is considered to be 3. Therefore, E of B will be equal to 1 plus 3 mod 26, which will be equivalent to 4. So the corresponding character to be replaced for B is considered to be E. So like this the process repeats, and if suppose we want to do decryption, which is considered to be the reverse of encryption, so see here it is done by the decryption of a particular cipher character will be equal to C minus K mod 26, where again the C indicates the cipher value and the K indicates the key value. So if suppose we want to do decryption for this D means, so here the value of D is considered to be 3, therefore 3 minus 3 mod 26, where 3 minus 3 is considered to be 0, therefore 0 mod 26 will be equivalent to 0. Therefore, for a particular cipher text T, the value decrypted to the original plain text value will be considered to be 0. So the corresponding character is considered to be A. So this is the process of the Cypher cipher. So under this, the cryptanalysis means how a third party can attack this corresponding cipher text and how they can return the original plain text. For example, you see here there are considered to be in the ciphers, that is the total number of characters will be always 26. So if suppose we are assigning or we are assuming the corresponding key value is to be, let us start from 1. So if P plus K mod 26, if K is considered to be 1, we can assume and we can check out and see whether the corresponding plain text is given. Like that we can substitute the various values for key and easily we can identify the corresponding plain text, cipher text and the corresponding plain text values. So this search is considered to be a brute force search. So there we are in the Cypher cipher, we can easily identify the cipher text and its corresponding original plain text. So in order to avoid that, we are going for the next cipher technique, that is considered to be the monoalphabetic cipher. So in this monoalphabetic cipher, instead of giving the positions, here arbitrarily they are changing shuffling the letters, and after that see here the plain text is considered to be all the characters, and in the cipher text randomly they are distributing the cipher text values such that for the given plain text randomly they are substituting the values, and after that they are substituting the corresponding cipher text values with the original plain text. So here the plain text for the I, it is replaced by the cipher text W, and for the plain text F, they are replacing it with the I. That is, here instead of giving any particular formula, here directly they are substituting, since in the cipher text randomly they are generating the values. So these are considered to be the various cryptanalysis for monoalphabetic cipher. That is under this, if suppose a particular character is repeated more than a single time, they are calculating the relative frequencies for the particular character and then they are substituting it for the original plain text. So for example, see, these are considered to be the various given cipher text, and for this they are any third party can attack this and they can assume the original plain text from this cipher text. So how they are assuming means they are counting the relative letter frequencies. That means how a single character, how many times it is repeated. They are calculating the frequency values, and after that, for example, if suppose we are guessing that for P, that is for the cipher text P, if the original plain text value is considered to be E, and for Z, if it is considered to be T means, then their third party can guess that if suppose ZW is considered to be a cipher text here, and if it is replaced by the TH means, then if suppose any character P is replaced here means, then we can assume that the word can be there, THE. Or similarly like this, the third party can assume here for each and every cipher text, they can assume the relative frequencies and then it can be replaced by the original plain text. Then the next one, so there also we can, a third party can attack the message. So in order to avoid this, we are going to the next technique, that is considered to be the play first cipher. So under this play first cipher, we can form a matrix value. So initially they are taking as 5 cross 5 matrix value. So here first we have to substitute the key value, and for the remaining positions we can arrange the alphabets in order. So for example, you consider here they are using the keyword as monarchy. So this monarchy will be substituted under 5 cross 5 matrix. So first they are substituting this values up to this under 5 cross 5 matrix, and after that they are replacing the remaining positions with the alphabets in order. So see here, the A already it is present in the keyword, so we cannot write in the next position. So after that B is not present here, so they are substituting B here next position, and C is present already in the keyword, so it is neglected, and the next alphabet is considered to be D, which is continued after B, and after that E, F, G, and H is already present in the keyword, so it is neglected, and the next alphabet is considered to be I. So here under this position, either it can be replaced by I or it can also be replaced by J. So under this position, it is considered to be I or slash J. Then the next position K, L, like that it continues up to the last character in the alphabet. And after this is the framed positions under matrix, and after by using this, now we are going to convert the plain text into ciphertext. So for example, you see here, now we are going to take the original plain text as this word balloon. So see here how many characters are present. Here 7 characters are present. So now we have to convert, 7 means it is considered to be odd number of position of characters. So now we are going to change it into even characters. So in order to change that, first we will be seeing which 2 characters are repeated. So see here, L and L are repeated twice. So under this repetition, we can convert this 7 position into 8 by inserting a character X. Therefore, here BA, LX and then LO, ON. So we are grouping like this into 2 characters each among this total characters in the word, and then now we are going to convert for each and every group under this character into a corresponding ciphertext. So see here, initially the first one is considered to be BA. So now you go into this matrix where BA is present. So BA is present under this single column. So there is a condition, if suppose any 2 characters are present under the same column, it can be replaced by the ciphertext. That is how they are going to replace, means they are going to replace it by means of by wrapping the next below character of the original. So if suppose we are replacing it by BA means, see here, we are going to replace, the first one is considered to be BA. So if suppose we are going to replace this BA means, B will be replaced by this next character A and A will be replaced by the next character X. So like that it can be replaced. Then the next one is considered to be the next character LX. So like that it continues. Here they have given the example first. You consider this AR to be the example. So AR is considered to be the same, which is considered to be present under the same row. So if any 2 characters are present in the same row means, again it can be replaced by the characters which can be wrapped by the below character. For example, you see here AR is present in the same row. Therefore, A can be replaced by the below character R and R can be replaced by the next character M. Therefore, AR can be replaced by the next character R and M. So that is they have given AR is encrypted as RM. Then see the next example MU. So see here M is present here and U is present here and both characters are present in the same column. So if both characters are present in the same column means, again that can be wrapped by the below character. So see here M can be replaced by the below character C and U can be replaced by the below character M. Therefore, MU can be encrypted as C and M. And the next condition you see here, if suppose we are going to replace any plain text other than these 2 conditions, that is under same row or same column. See for example, we can consider HS. See H is present here and S is present here, and both are considered to be not in the same row or in the same column. Therefore, we can take the diagonal condition for this, and H can be replaced by this B and S can be replaced by this P. So, such that they are replaced by H's as B and P. So, similarly like this, we can substitute the various plain text into ciphertext under this Playfair cipher. So, under this Playfair cipher, initially we are considering the 5 cross 5 matrix, but here we can consider the total number of alphabets to be 26. Therefore, we can cross a matrix as 26 cross 26, which is considered to be 676 diagrams. So, according to this, if suppose we are forming an encryption by means of this, and if we are getting a ciphertext, the third party may find it difficult to convert it into original plain text. So, this is considered to be the Playfair cipher, and the next one is considered to be the polyalphabetic cipher. So, under monoalphabetic cipher, we will be considering only a single cipher technique, but under this polyalphabetic cipher, we will be considering multiple cipher alphabets, such that it will be difficult for anyone to break the ciphertext into original text. See here, we are considering the row-wise characters and also the column-wise characters, and it can be replaced by the positions present in between here. So, for example, you see here, the next one is considered to be the Wigner cipher, which is considered to be the simplest form of polyalphabetic substitution cipher. So, here we can see the example. See that they have given the key to be deceptive, and the given plain text is considered to be we are discovered, say yourself. So, if suppose we are substituting for this key value with the original plain text, means the given key value will end up to this, that is deceptive. And again after this, we are having the characters under plain text. So, in order to do encryption purpose, we are going to repeat the same characters present in the key up to the characters present in the plain text. And after this, how we are going to encrypt this by means of this key value means, now we are going to consider this table, and we are going to replace for the corresponding key value and the plain text value which is present inside this table. So, see here, for example, the key value is considered to be D, and for the corresponding character the plain text value is considered to be W. So, we are going to see here the key value will be taken under this row wise, and the plain text character will be taken under this column wise. So, under this D, they will be seeing what is present under this X. Therefore, it can be see under D, and here this is considered to be the plain text character W, and the key value is considered to be D. So, here we will be getting the encrypted value to be Z. So, that is replaced here. See, for D in the row and W in the column, the replaced character is considered to be Z. Okay. So, this is considered to be the converted ciphertext by combining this key and the plain text value. So, this all these techniques what we are considered is considered to be substitution ciphers. That is, we are going to substitute any characters by combining the key value and the plain text value. And the next one is considered to be this transposition ciphers. Under this transposition cipher, what we are going to do means we are going to change the positions of each and every character under the text, original plain text. So, see here, this is considered to be one of the method under this transposition cipher, that is considered to be the rail fence method. So, under this rail fence method, we can assign a depth value for this. So, here they are assigning the depth value to be 2. So, see here, this is considered to be the original plain text, that is meet me after the toga party. So, now what they are going to do means just they are going to change the positions of the original plain text, and then they are going to combine the changed position letters, and then they are going to form the ciphertext. So, see here, they are going to arrange it by means of a diagonal value. See, M is present here, then E is present here, then the next character, then the next character, like this it goes like a rail method. So, here after framing like this, arranging like this, now we are going to combine the first position characters, and then we are going continued by the second position characters. Therefore, ME, MA, like that it continues, and after finishing this Y, we will be continuing with this E. So, this is considered to be the converter, that is the encrypted ciphertext by means of this rail fence method. So up to this, what we have seen is considered to be the classical cipher techniques, where we are using this substitution cipher and transposition cipher. Then the next one is considered to be the conventional encryption techniques. So under this conventional encryption techniques, these are considered to be the various modern techniques used under this. The first one is considered to be the simplified DES. The DES means it is considered to be a data encryption standard, and the next one is considered to be the block cipher principle, and the next one is data encryption standard, block cipher design principles, and block cipher modes of operation. So now we can see about what are the basic principles under this SDES and how they are converting the plain text into ciphertext. So see here, this is considered to be the SDES method, that is the simplified data encryption standard, and under this main technique, the main concept of this is considered to be, it is a block cipher method where we are going to use a 10-bit key, and here the plain text given is considered to be 8-bit, and initially here there are 2 rounds to be used. So under the first round they will be following this technique. Again under the second round the same process will be repeated. So under this you consider here under encryption, what are the various processes to be repeated is, the first one is considered to be the initial permutation process, and the next one is considered to be the function, where under this function they will be mixing both this permutation, and then the next one is considered to be the substitution, and after this function they will be producing an output, where under this output gets swapped in between the left value and the right value, and again after this it is given to a function. This is considered to be a first round function, and the next one will be the second round, and finally we will be taking the inverse of this permutation, and then we will be getting the 8-bit ciphertext. So under each and every function we will be using some key value to mix the permutation along with the substitution. So for this each and everything, the 2 keys are produced since 2 functions are used. So for the first key they will be generating in this process, and for the second key again they are continuing this and doing another 2 processes to get the second key. So how they are generating the key value means, here also they are combining 2 permutation values, one is considered to be the P10 and another one is considered to be P8. So in order to do all this process, see here the first one is considered how they are going to generate the key values. So here a 10-bit key is given and is permitted to this P10, and after that the permitted 10-bit value will be subdivided into 2 5, and the first 5 is given to this left shift, and the second 5 is given to the next left shift, and after this output is given to the permutation 8, where the given output value is considered to be K1. And here after doing the left shift to 1-bit position, again it is given to the left shift to the 2-bit position, circular left shift. Similarly here also it is repeated, and obtained value is given to the P8, where it is permitted to 8 bits, and this is considered to be the K2. So now we can do a problem according to this SDES value, and we can see how a given plain text is converted into the ciphertext. So this is the basic process of SDES, that is the simplified data encryption standard. So under this already we have seen that is 2 processes going to be done. One is considered to be the encryption and the next one is considered to be the decryption. And under this encryption, these are the various steps to be continued. The first one is considered to be the initial permutation. So before the 8-bit plain text will be given as input to this initial permutation. After doing permutation, it will be given to the function, and some function is done under this, and then the output is given to the swap, where under this the both left and the right value will be swapped, and after swapping it will be given to this function, and after performing a function here it will be given to the inverse of the initial permutation, which in turn the output will be considered as the 8-bit ciphertext. So under this doing, in order to do this function, it will get the value of this initial permitted value along with the generated K1 value here from the generated 10-bit key, and after that, in order to do the second function, again we are in need of K2 value in order to perform the function, and then it is given to the inverse of initial permutation, which in turn we will get the 8-bit ciphertext. and then the same process is repeated in reverse in order to get the 8-bit plain text from the 8-bit cipher text what we are obtaining here. So we are going to perform two functions here, and for the first function we are in need of the key value k1, and for the second function we are in need of the key value k2. So in order to get these values, now we are going to the process of key generation. So under this key generation, initially we will be assigning a value which is considered to be a 10-bit key, and then this 10-bit key is inserted into the permuted value to 10 bits, and then it is given to the shift value, where here we will be doing shift to one position, circular left shift, and after that this is given to the permuted to P8 value, which in turn is considered to be the K1, which is used for the first function. Then for the second function, after doing the shift, this is again it is given to the next shift, where we are going to perform circular left shift to 2-bit positions, and after that this will be given to permuted 8, which in turn gives the K value K2, which is given to this function, and after performing this we will be going to the inverse permutation. So now we can do a problem for this. So in order to proceed with the problem, first we have to generate the key values k1 and k2. So in order to generate k1 and k2, this is considered to be a key generation function. So in order to generate the values of k1 and k2, first we are in need of a 10-bit key to be assumed. So here we are assigning a key value to be, that is this 10-bit key is considered to be, this is considered to be a 10-bit key which is given as input to this key generation. So this 10-bit key which will be given to this permuted value of 10 bits. So this is considered to be, the P10 is considered to be the values 35, 274, 101, 986, and this is the value of P10, and then the next permuted 8 value is considered to be 63, 74, 85, 10, 9. So these are considered to be the various position of the characters to be present. So under this you see here, for this the permuted P10 value is considered to be this, and this is considered to be a 10-bit key value what we have already given. So these are considered to be the various positions to be present. See, this is considered to be the various 10 bits present, and these are considered to be their corresponding bit positions, and now we are going to rearrange these values according to the positions present under this P10, because we are inserting this key value to this P10. So after this, how we will get the value at the output of this P10 means, the first position is considered to be third position, that is this will come under first, that is the output of P10 will be 1, and the next one is considered to be the fifth position, this is 0, and the next one is considered to be the second position, that is 0, and the next one is seventh position, that is 0, then the next one is fourth, 0, 10, which is 0, 1, which is 1, 9, 1, 8, 0, then 6, which is considered to be 0. So this is considered to be the output of this P10, which will be given here. Therefore, the output of P10 is considered to be 1, 0, 0, 0, 0, 1, 1, 0, 0. So totally we are getting So totally we are getting 10 bits at the output of P10. And the next step is, now again we are going to subdivide into two groups, where the first 5 bit will be given here and the second 5 bit will be given here. Therefore what we will get here, 1, 0, 0, 0, 0, and here we will get 0, 1, 1, 0, 0. So what we are going to do here means, it is given to this part where we are going to perform a circular left shift to one position. Therefore, see, this 1 will go here and then the remaining bits will move to their corresponding left position. Therefore, the output of this LS1 will be 0, 0, 0, 0, 1, and here this 0 will move here and the remaining will move to the next positions. Therefore, the output will be 1, 0, 1, 1, 0, 0, 0. So, this is considered to be the output of left shift to one position to the left. So, what we are going to do means, we are going to combine this two and then it will be given to this P8, which in turn generates the value of K1. Therefore, the output of combining that LS1 will be getting 0, 0, 0, 0, 1 and 1, 1, 0, 0. So, this will be given inserted into this P8 such that according to this positions we are going to substitute the value. Therefore, P8 we will get, P8 will be, see for this we will be assigning the positions. So, the first position letter is considered to be 6 and the second position is considered to be 0, then the 7th position 1, 4th is considered to be 0, then the 8th is considered to be 0, and the 5th is considered to be 1, and the 10th one is considered to be 0, and the 9th one is considered to be 0. So, this is considered to be the output of the permutation 8, which is considered to be the value for the K1. Therefore, the generated K1 value will be the output of this P8, that is 1, 0, 1, 0, 0, 1, 0, 0. This is considered to be the value of K1, which can be used for the function under the encryption. Then after this, now we are going to generate the next key value K2 from this. So, what we are going to do means, the left shifted value of this will be given to this LS2. Therefore, see here, this is considered to be the output of this LS1, that is 0, 0, 0, 0, 1, and now this value will be given to this circular left shift to the 2-bit positions to the left. Therefore, this 2 bits will be moved here and the remaining will be moved to the left. Therefore, the output of this LS2 will be 0, 0, 1, 0, 0. Then the output of position to the next 5 bits is, see that we are getting 1, 1, 0, 0, where here initially we will be considering the first 2 left bits. So, here this is considered to be the first 2 which will be moved here and this will be moved to their left positions. Therefore, we will get 0, 0, 0, 1, 1. Therefore, the output of LS2 will be 0, 0, 0, 1, 1. So, this is the value of LS2 present here, that is 0, 0, 1, 0, 0 and 0, 0, 1, 1. So, totally we will be getting 10 bits, which in turn is given to this permitted to 8 bit. So, under this P8, again this is considered to be the positions under P8 and the obtained 10 bit value is 0, 0, 1, 0, 0, 0, 0, 1, 1. So, now you assign positions for each and everything. So, now we are going to permute this to P8 value. So, after doing permutation, what we will get, the first bit is considered to be 6, therefore, 6th position is 0 and the next position is 3, that is 1, next position is 7, 0, then 4, 0, then 8, 0, 5 is considered to be 0, then 10 is 1 and 9 is 1. So, this is considered to be the obtained key value K2. Therefore, K2 will be equal to 0, 1, 0, 0, 0, 0, 1, 1. So, this is the obtained K value. So, from this key generation, initially this is considered to be the first step to calculate the value of K1 and K2. So, after generating the key values K1 and K2, now we are going to the encryption process where we are going to convert this 8-bit plain text into 8-bit cipher text. So, here consider the plain text, what we are going to give us input to be, that is the 8-bit plain text is, consider this is considered to be the 8-bit plain text, what we are going to given as input to this step. So this is given as input to the initial permutation. So here the value of initial permutation is, this is the assigned positions to change the original plain text. Therefore this output of IP will be equal to, initially we have to substitute the second position. So first we can assume the positions. So now we are going to convert this according to this initial permutation position. Therefore first we will be getting 1, and the next one is considered to be 0, and the next one is considered to be the 1, and the next one 1, then fourth one is considered to be 1, and the eighth one is considered to be 0, and the fifth one is considered to be 0, and the seventh one is considered to be 1. So this is considered to be the output what we are getting after giving the original plain text into initial permutation. So this will be given here, where under this again we are going to subgroup into 2 equal parts. So here first we will be getting the leftmost first 4 bit, and this will be the rightmost 4 bits. Therefore the first 4 bits will be given here, that is 1 0 1 1, and the remaining 4 bits will be given that is 1 0 0 1. So what we are going to perform here means, the leftmost bit will be present as it is, and now we are going to perform a function only for the rightmost 4 bits. So this 4 bits will be given to this expand or permutate value, where we are doing, what we are going to do here means, this 4 bits will be given as input to here, and under this they will be doing permutation after expanding their 4 bits to 8 bits. So see here, this is considered to be the position values under expand or permutate. So initially what we are going to give as input, we are going to give as input as 1 0 0 1. So these positions will be 1 2 3 and 4. So now we are going to expand this 4 bits into 8 bits under this ERP. Therefore first we will be getting the 4th bit position value, that is 1, and the first one 1, and the second position 0, and the third position 0, again the second position 0, third position 0, fourth position 1, and the first position 1. So this is considered to be the output of this ERP. Therefore here we will get the value to be 1 1 0 0 0 0 1 1. So this will be the obtained value as the output of this expand or permutate. Then in the next step what we are going to do means, now we are going to do the XOR of this value with the already generated key value of this K1. Therefore here we will get, first we have to do the XOR with this K1 value. So this is the obtained output of ERP, and the K1 value is 1 0 1 0 0 0 1 0 1 0 0 1 0 0. So this is the obtained K value. So now we are going to do XOR of these two values. So what will be the condition of XOR? If any one is considered to be 1 and the next value is considered to be 0, means we will be getting the output as 1. If both the inputs are considered to be same, we will be getting a 0. Therefore see here we will get 1 1 1 0 0 1 1 0. So this is the obtained value after doing XOR with the K1. So that will be given, that will be the output under this stage. Therefore we will get here 0 1 1 0 0 1 1 1. So this is the obtained 8-bit values after doing XOR of this output with the generated K1 value. So now again we are going to subdivide this into 2 parts, where this 4 bits will be given to S0 box, and this remaining 4 bits will be given to the S1 box. So S0 or S1 boxes are given here. Again here we are repeating we are assigning the positions of each and every particular character. So here 0 0 will be considered as 0 0. This is 0 1 1 0 1 1. Similarly here 0 0 0 1 1 0 1 1. So now we are going to check in this value, and then we are going to replace the 4-bit value into 2-bit value. So what is the first 4 bits? These 4 bits will be given as S0 0 1 1 0, and here we will be getting 0 1 1 1. So here this bit and this bit will be considered for row wise, and this two will be considered for column. That is, the 0th position element and the 3rd position element will be combined and it will be considered for row wise. Therefore, 0, 0, this condition, this position is taken. Then the remaining 2nd and 3rd bit will be considered for the column wise position. So here 1, 1. Therefore, under 0, 0, we are going to consider 1, 1. Therefore, we will be getting this value for 0, 0 and 1, 1. So, for 0, 0 and 1, 1, we are getting what? We are getting the value as 2. Again, it should be converted into binary. Therefore, for 2, we will be getting the value as 1, 0, which will be given here. Thus, the 4 bit is converted into 2 bits by inserting it into the S0. Then now, again, we are going to repeat the same process for S1. What we are doing, what we are getting 0, 1, 1, 1. Therefore, here it is 0, 0, 0, 1, 1, 0, 1, 1. Therefore, we have to see the position 0, 1 under row wise and 1, 1 under the column wise. Therefore, this, and we will be getting this. Therefore, this position will be 3. The obtained binary value will be 1, 1. So, here we are getting 1, 1. Therefore, the output of S0 is considered to be 1, 0 and the output of S1 is considered to be 1, 1. Now, we are going to combine this 2 bits such that we will be getting the 4 bits. Therefore, the output of P4 will be 1, 0, input of P4 will be 1, 0, 1, 1. So, now this will be given as input to the P4, and after giving as input, this is the value of considered to be the permitted to 4. Again, now we are going to rechange the positions according to this P4. So, initially the input for P4 is 1, 0, 1, 1, and now we are going to change this to the according to this position. Therefore, for P4 we will get the second position first, that is 0, the fourth position 1, third position 1 and the first position 1. So, therefore, this is the obtained P4, that is 0, 1, 1. Here we will be getting 0, 1, 1. And then the next step what we are going to do means, we are going to combine this and this, that is 1, 0, 1, 1 along with 0, 1, 1, and after that, that is done XOR with this K2. So, first we have to do XOR of this, that is 1, 0, 1, 1 and 0, 1, 1, we will be getting 0, 0, 1, 1. So, this is the obtained value here, that is 1, 1, 0, 0, and in the next step we are doing XOR with the K2. So, the obtained P4 value is considered to be 0, 1, 1, and this is done XOR with the leftmost 4 bit, that is which is kept as it is, that is 1, 0, 1, 1. So, we are doing XOR of both these two, 1, 0, 1, 1 and this obtained value 0, 1, 1, and finally we are getting the output as 1, 1, 0, that we will get here 1, 1, 0. So, in the next step what we are going to do is, this is considered to be the first round, and in this S we are going to continue with the next round since we are having 2 rounds. So, here this obtained value is present here under leftmost value, and the rightmost 1, 0, 1 will be here, that is 1, 0, 0, 1, and here what we are going to do is, the next step we are going to swap this leftmost bit with the rightmost bit. Therefore, this 1, 0 leftmost will be considered to the right and the rightmost bit will be considered to the left. Again, the same process is going to be repeated. So, under this process, instead of K1 value, we are going to consider the K2 value. What we are getting here is K2 is considered to be 0, 1, 0, 0, 1, 1. So, the same process will be repeated with this obtained K2 value, and the final output will be considered to be the 8-bit ciphertext. So, this is considered to be the encryption process under SDES, how we are going to convert the plain text into ciphertext. So, under the next process, what we are going to do means, the rightmost bit is considered to be the leftmost, and then here it is considered to be the rightmost where we are going to perform the operations. So, see here we will be getting as 1, 0, 0, 1, and here we will be getting as 1, 1, 0. So, under the 1, 1, 0 is given to this expand or permutate, that is this 4 bits is converted into 8 bits by means of this expand. Therefore, what we will get? see here, this is considered to be the positions under expand or permitted. So initially we are giving as input to this, that is this 1100, therefore 1100, and this is corresponding positions, and the obtained ERP will be, first position is 4th bit, that is 0, 1, and the next one is considered to be 1, and the next one is considered to be 0, 1, 0, 0, 1. And this is the obtained value of this ERP. So now substitute this ERP here, that is what we are getting, 0, 1, 1, 0, 1, 0, 0, 1. Then in the next step, what we are going to do, we are going to take this output and then we are going to consider the value of key 2. Both are XOR under this XOR function. Therefore, the obtained K2 value is considered to be, K2 is 0, 1, 4 zeros, 1, 1, and the obtained ERP value is considered to be 0, 1, 1, 0, 1, 0, 0, 1. Therefore, by doing XOR of this both, here you will get 0, 1, 0, 1, 0, 1, 0, 0. So, this is the obtained value after doing the XOR function. So, this will be substituted here, that is we will be getting 0, 0, 1, 0, 1, 0, 1, 0. So, this will be given as output after this XOR, and what we are going to do means we are going to again subdivide into 2 equal parts. So, this first 4 bit will come here, that is 0, 0, 1, 0, and here input to S1 is considered to be 1, 0, 1, 0. Again what we are going to do, we are going to convert this 4 bits into 2 bits by inserting into S0. Similarly, the same thing will be done under this remaining 4 bits to S1. Therefore, here the first and the last bit portion is considered to be 0, 0, and this is considered to be 0, 1. Therefore, under S0, this is considered to be 0, 0, and this is considered to be 0, 1. Therefore, the bit position element is considered to be 0. Therefore, here initially we will get 0, 0. Then under S1, we are going to consider 1, 0, 0, 1. Therefore, under row wise we have to consider 1, 0, and under column wise we have to consider 0, 1. Therefore, 1, 0, 0, 1 will get again 0. Therefore, here also we are getting 0, 0. Therefore, the obtained P4 value is considered to be 4 zeros, that is 0, 0, 0, 0. Again, we are going to permutate according to this P4 value. So, under this P4, it is considered to be the second position, fourth position, third position and the first position. Since we are getting all are considered to be zeros, here the output will be considered as 4 zeros. Then what we are going to do means, we are going to do XOR of this value with the rightmost value what we have done, that is 1, 0, 0, 1. Therefore, the XOR of 1, 0, 0, 1 with 4 zeros is considered to be 1, 0, 0, 1. Therefore, the obtained 4-bit value will be 1, 0, 0, 1. And now what we are going to do means, we are going to give this, we are combine this value with this swapped leftmost value, and then this will be given as input to the inverse of initial permutation. Therefore, the combined value will be, after combining we will get the value as 1, 0, 0, 1, what we are getting as output, and then the swapped value, that is the swapped value is considered to be 1100. So, this is considered to be the input to this initial permutation. Then this will be changed according to the positions by means of this, that is 4, 1, 3, 5, 7, 2, 8, 6. So, according to this position we are going to rechange it. First we write the positions for this and the obtained value of this IP inverse will be, first one is considered to be the fourth position 1, the next one is considered to be the first position 1, and the third position is 0, fifth position is 1, seventh one is 0, second one is 0, eighth one is 0, and the sixth one is considered to be 1. And this will be the output of the inverse permutation. Therefore, what we will get, the obtained value for this 8-bit ciphertext is considered to be 1101 0001. So for given plain text 8-bit, we are converting by this encryption process under SDIS, and we are getting this as the output 8-bit ciphertext. So by means of this SDIS, we are combining two rounds in order to get the ciphertext. Initially we are using the block cipher principle, that is we are considering the block as a text, and here two rounds are considered and the 10 bits are considered to be key. So for any third parties it will be found to be difficult in order to go this two rounds and also to assume the various key values. So this is considered to be the one of the conventional encryption techniques under this cipher.